So we're going to talk about the project. I'll share my screen, the project document, and go over it. And after I'm done, I'll briefly go over it, and then you can ask questions, and then we'll proceed to the class. So that is how we're going to progress today. So once again, welcome to session 21. This is the 21st class session we're having, and the in the 11th week. All right, so we are rounding up already. We've come a long way. All right, so let me quickly share my screen. Hope everyone can see my screen. Please confirm in the group if you can see my screen. All right, all right. So as you can see on the screen here, this is your capstone project. Um, So the project basically is okay. These are some information here. This is the title of the project: income level prediction. So you have to build a machine learning model that will be able to predict the income level of individuals, right? And the timeline is from 10th of September. That was this week until 22nd of September. So you have 2 weeks for the project. So please try as much as you can to do it between or to do it within this timeline. And the deliverable for the project is a Jupyter notebook. All right, so you know what a Jupyter notebook is. So it should contain all your code and non-code tasks. So everything that you are doing, whether you are explaining what you did, or you are giving recommendations, or you are giving insight, or what have you, whatever it is you are doing, they should all be included in your Jupyter notebook. All right. So that is what I'm expecting as your deliverable. I don't want a PDF. Neither do I want a Google Doc, right? So this is what I expect you to submit, a Jupyter notebook. Now the project overview. So the aim of this project is to develop a machine learning. Let me put, the aim of the project is to develop a machine learning model to predict whether a person's income exceeds 50K per year, $50K per year based on census data. So you should already know that this is a classification task, all right, based on the data that you were given. So by leveraging the particular data set that you gave us, you will explore the data, engineer relevant features, build and evaluate your predictive model, and provide insights from your data. So this is just the overview of the project. This is what you are expected to do. So there was something I said here, I wrote here that you should feel free to be creative about different ways you can make your model better. So one thing I like about prep people is when they try things that are not necessarily that are not just what they were taught. So the reason why we teach you things is just to give you a foundation, right? So just try different things. Like the things that we're going to be discussing in today's class, you can try it as well. All these things will actually have additional marks. So once we go to the criteria, you're going to see it there. So these are all the steps. I don't need to go through all this thing again. These are the things that you already know. You import your data, you inspect your data, EDA, and the EDA, you can see that I told you should generate at least 5 meaningful insights, at least, so you can generate more, but at least you generate 5 meaningful insights from the data with appropriate visualization. So I need you to actually take your time on this EDA aspect. So it's not just the ML that you are doing. So the EDA is also part of it, and with appropriate visualization. So I don't want any of the chart. You should not just do your chart anyhow. There's a reason why we went through all those customization that we looked at matplotlib. Apply them, apply styling, color, transparency, all of things just to visuals appealing. So it's going to carry marks too as well. So after that you process your data, feature engineering. So we looked at this already. Okay, so you see here, I said you can also try out different feature engineering and processing techniques, PCA, feature selection, etc. So we've not done this, we're doing this today. So after today's class, you have an idea of what these things are and how to apply them, right? So then you move on to developing a model using different algorithms, okay? And I said you should train your model and optimize hyperparameters, right? So all the things we've done, you should use them in this project. So there's another step here, which is the last step, which is saving your model. So I've not taught us how to save our model here. So in tomorrow's class, I'm going to show you how you can save your model. Once you train your model, you can actually save it as a file, right? So if you, let's say, save it as a file, you can send it to another person to use. So that person can you can download the file and open the digital notebook and use that model to make predictions, right? So that is basically how it can be used. So that file, that model that you save, is what is usually is what is used in deployment most of the time. So, but this is where we're going to be stopping. We're going to look at how we can save our model, right, for future use. So you don't just have it in a notebook, right? You can actually have your model that you trained as a file. So we'll see there's a library we use for that. We're going to look at that tomorrow's class. So, and then you have to summarize and give recommendations. So summarize key insights from EDA, highlighting any patterns or trends observed in the data. Also discuss the performance of a machine learning model, its effectiveness in predicting income level, and how it can be improved. So these are the steps that I expect you to follow. Like you can add your own, you can add additional things, but this is the general step. These are the steps I expect you to follow. So you don't have to be so strict with every single detail I put there just to guide you. You can be creative as well. So this is just the overview of the project. Now I gave us grading criteria here. So I'm trying to be as transparent as possible. So you see when you get your grade, you know where it is that you didn't do well. So this is going to even help you to know the one you are missing or the one you have not done yet. So you can see that every aspect, a lot of different categories have their own marks. Some have higher marks, some have lower. So the first one is project introduction. So this is a project, right? This is not your usual assignment. So I expect an introduction. I expect, like, once I am looking at your project, I assume that I don't know anything about your project. So your introduction should give me an insight. You can even include images in your introduction, like images of maybe you be creative. You can embed an image that represents income, something like that. So you can just give an introduction that it is blah 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 income base. So we are trying to build a machine learning model that will help predict. So just think of although you have to give the project overview first. So just be creative. That's just all I will have to say. I don't want to say anything more than that. So you introduce your project. So if someone that doesn't know anything about the project reads it, they should be able to understand what the project is all about and what it is that you want to do. And now library import structure. So I also give marks to how you import your library, how you categorize them, how you also comment on the different libraries that you're importing and put them in different categories. So yeah, so that one has its mark as well. I also have data exploration and cleaning. You know what this is. It's 10 mark. EDA is 15 marks. All right. Data preprocessing and feature engineering is 10 marks. Hyperparameter tuning. So if you know you do hyperparameter tuning, just know you are already losing 10 whole marks. Model evaluation, 10 marks. So model evaluation is different from model performance. So model evaluation is just the technique and the method you used in evaluating your model. So I need to see exactly how you approached it, what you did, and all of that, right? So also model performance as well. So if your model has a high accuracy, you have higher mark. If it has a low accuracy, you have lower marks. So that's just what this one is all about. So insights, you have to summarize your insights from your project. It has 10 mark recommendations, 5 mark code clarity and comments. So I also look at how well organized and neat your code is, and how easy it is to read and understand, and also how you commented on your code. So that will be 5 marks. All right. So now the last one is overall project structure and organization. So also be looking at how you structured your projects, like how you use Markdown and all of that, to just make the notebook very appealing. All right, so it's also going to have its mark. So if you want to get the most out of this, just try following all these criteria that is listed here. All right, so that is it for the project. That is it for the project. All right. Now I'm going to be taking questions. So just like few minutes before, let's say 8 minutes, I'm going to take in questions. So if you have questions regarding this project, please let me know, and then we'll move to what we have for today. All right, Kechika Collins, please go ahead.
Hi, good afternoon, sir. Good afternoon,
Yeah, good
everybody.
afternoon.
Okay, just to seek more clarification, you were saying that the Jupyter notebook should contain all our codes and non-code tasks. Is it just one Jupyter notebook we send at the end?
Yeah. I expect you to send us one Jupyter notebook, so
Okay.
everything should be contained there.
Okay, not as if we are going to separate all the ones that have code, all the ones that have program will do on different notebook. The ones without code will do on a different notebook.
No. Everything should be in one notebook.
Okay, sir.
Yeah.
Thank you.
All right. So any other question? Any other question? Please ask question, or like this is an opportunity to actually get clarity on the project, because I will definitely try to answer your questions during the week, but you might not get it like this. So please ask your questions. All right, Jeffet, please go ahead and ask your question. You're on mute.
Okay, good evening, sir. Good evening, everybody.
Yeah, good afternoon. Good afternoon, good
Good
evening.
afternoon, Barry. The census data we are using, is there any specific one, or we're just going to use anyone? Like, I don't know if you understand.
Okay, it is the data attached to the assignment that you'll be using, the one attached with the project.
Oh, okay.
There was a data set that attached to the project on Google Classroom, so that's what you'll be using for that.
Like, you sent a different one, because the only one I having here is the Excel sheet.
Yeah, that's what I'm saying. That was the one I attached with the project. So that's the data set that will be used for this project.
Okay.
Yeah. All right. Favor. Favor, please ask a question. Unmute. You can unmute yourself, Favor, and ask a question. I've unmuted you.
Good
Hello.
afternoon, sir.
Yeah, good afternoon.
Yeah, so yeah, for the project, you said we can use like Google Colab for the project. Now, using Google Colab, the project structure is going to look different because now with Google Colab, one has to mount the Google Drive and install some the normal Anaconda using Anaconda or using Anaconda would look like.
If you want to use Google Colab, you can use Google Colab. You just have to go through the stress of setting up all the libraries that are not in Google Colab already, because I think Google Colab has some libraries that are inbuilt. But I don't think you should have much
Yeah,
issues using Google Colab for the project. So if once you are done with
yeah,
it, you can just download the file and upload. Yeah.
all
So
right.
that is just it. It shouldn't be a problem actually.
Hello.
It shouldn't be a problem. Yeah, I can hear you.
Okay. Yeah, because the reason I asked was because like yesterday it took me like for over 2 hours and 45 minutes. I was trying to use the to do the hyperparameter tuning, and for 2 hours 45 minutes it was not it didn't work. So when I used Google Color by it was done in less like than 20 minutes. So
Yeah. That is one thing about it, because I said it before, the hyperparameter tuning, depending on what it is you are doing, it might take a lot of time, right? To go through all the hyperparameter combinations and get the best performing model. So if you are using your local, if you are training it locally on your computer, depending on the specs of your computer, if your computer has a GPU, then it will be fast. But if it doesn't have a GPU and just, let's say, a normal regular Intel CPU, you might
yeah, mine,
you might find it might take a long time for it to train. So I understand where you're coming from. So that's why you have this time to do all the things you need to do. If you are using it locally, you still have enough time. You can train it for that amount of time and get your get the combination and then proceed with the model and all of that. So yeah, but using Google Colab will save you a lot, and also using Kaggle as well will save you a lot if you know how to use those ones.
all
So
right.
yeah, thank you for the
Thank,
question.
yeah,
It's good
thank you.
to explore actually, because there are a lot of tools out there that you need to know as a data scientist. Right.
Thank you.
All right. Thank you. So I'm going to be calling on Adams. Adams, please ask your question. Adams, please ask your question. Yeah, I'm mute now. Adams, please can you unmute yourself and ask your question? Hello. Please, you have this opportunity to get clarity and feedback and whatever it is you want to know regarding the project. I'm going to still respond to your questions during the week, but it is not going to be you can't compare it to what you have now, the opportunity you have now. So due to how tight my week is going to be, I might not respond immediately. So please ask your questions now.
Good afternoon,
Adams,
sir.
I can hear you. Yeah, good afternoon.
My question.
Hello. Hello. I was hearing you. I think you muted yourself again. So all right. You know what? We're going to proceed from here. I think I've given enough time for us to ask questions. If you have any other question, then you can bring it to my DM and then we'll look at it. So please pardon me today. I might not be able to raise my voice because I don't know why, but I'm having a very serious headache. So please try to pay attention. Although today's class is just like let's say extra information that you need to that you it's good to know. All right, it's something that would be nice to know, or nice to have, right? In nice to know in SQL. So let me share my screen. All right. So. Please let me know if you all can see my screen. All right. So today's class, we're going to be looking at three things. Okay, we're going to be looking at principal component analysis, that is PCA. We're going to look at feature selection, and we're going to look at building pipelines in Sklearn. So these are the three things we are looking at. There are techniques that you can apply when building your machine learning model. Very, very useful techniques, and you will see why in a few minutes. So now, before we move on into PCA, I need to introduce us to what we know as the course of dimensionality. Okay, so the course of dimensionality. I think I've mentioned this in a previous class. Please, can someone confirm if it has been mentioned already, or this is the first time we are mentioning it in class? Okay. Anyways, but we'll still have to go through it again regardless. But today we're going to be looking at these things, and I need us to understand what the course of dimensionality is first. Okay, so now you all know what dimensions is in when it comes to machine learning. It corresponds to features, right? I've said it several times that the higher the dimension of the data set, the higher the feature. So it's just the same thing. It's just different ways of referring to the same thing. Okay. So now the course of dimensionality is a problem. It refers to problems that arise when working with high dimensional data. So high dimensional data is not always good, right? It's not always a good thing to have a data set with lots of features. It might be good sometimes, but it is not always good. So there are problems that can arise. All right. So in machine learning, we have this problem, which is the course of dimensionality. So in summary, what it means is that as the number of features or dimensions increases, it can negatively impact the performance of machine learning models. All right. So I just want someone to tell me why this is true or why this is the case based on last week's Sunday's class. As the number of features increases, we might begin to have a model that would not really perform very well. Why? Can someone tell us why? Like why this problem can arise? Although I just remember that the recording for last class was just re-uploaded yesterday. So I'm thinking that we might not have gone through the class again. So I'm going to just answer the one. But does anyone have anything to say or an answer to that? Okay. Thank you very much, Michael and Douglas. Overfitting. That is just the answer. That is just the answer. Overfitting. I told us that I explained what overfitting is in the last class, and I gave us how overfitting can happen. And one way overfitting can happen is when we have too many features. All right, too many features. So this problem now that we're looking at, it applies mainly to these traditional ML algorithms. When you enter deep learning and you start looking at neural networks and all of that, it doesn't actually apply to those ones because those algorithms, they are more complex and they can actually take in more features without having poor performance. In fact, the higher the number of data sets and features, all of that, the better the model serves. So this problem applies mostly to traditional ML. The traditional ML basically mean the ones that we've been looking at, right? So that is what cost of dimensionality is. So let's just proceed with it. As you can see this graph now, which represents what we just explained. So on the y-axis, we have the performance. On the x-axis, we have the number of features. So you can see that the highest performance of that model was seen when the number of features was just at this point here. So maybe just a few features. I don't know the scale that was used there, but this is just showing you that the performance, it does not correspond to the number of features. So it gets to a certain number of features that the performance reach the highest level, and any additional feature will lead to a drop in the performance of the model. So you can see how the performance started dropping as the number of features increase. So this is what is known as the cost of dimensionality in machine learning. So something that can happen. So when you have a data set with too many features, like when I say too many features, I mean too many features. All right. So we can have like too many features, like 500 features, 200 features, 1,000. Data set can actually have like 1,000 features and all of that. So when I'm saying too many features, I don't mean features like 20, 50, 40, and the likes. So you should just keep that at the back of your mind. All right. So now we're going to look at some key concepts before we move on to how we can address that issue. So I've explained what the cost of dimensionality is. So the cost of dimensionality occurs when adding more features makes data analysis and model training harder. With more dimensions, data point becomes sparse, making it difficult for models to learn patterns. So this is basically what happens. And the implications increase computational cost, sparsity of data, distance metrics, model complexity. So all these are attributed with the cost of dimensionality. So I've not really got deep into all this. These are just explanations. So okay, let me just briefly. So examples like for instance now in a 2D space, a circle can cover a lot of points, right? While in a 10D space, a similar hypersphere cover much less of the space. So this is just trying to help us understand um how dimension, right, actually how dimension is difficult to to deal with or to handle. So in 2D and 10D space, we're trying to see that in 2D space now, a circle can actually cover a lot of points. Why I'm looking for how else to explain it, because when it comes to dimension, it's a very abstract concept. So I won't want to bore us with that, right? But just understand that the higher the dimension, the more difficult and complex it is for your algorithm, especially these algorithms that we're looking at now. Does not really apply to neural networks and AI algorithms and the ones that are in deep learning. So if you look at or you decide to advance yourself, you're going to meet them. So a practical example, a data set with 100 features can lead to overfitting if not properly managed. Okay, so this is just an example of what we are discussing here. So now we've looked at the problem. What's the solution? So we have different ways that we can handle the dimensionality problem. So the first one is the dimensionality reduction technique. So dimensionality reduction technique, these are techniques that can be used to reduce the dimension. Basically, that's what it does. All right. Now, before I explain further, let me just introduce this other one, which is feature selection. So we have dimensionality reduction technique, we have feature selection. Now, these two are quite different. Feature selection technique here, what it does is that it just selects a certain number of features that are more important and relevant to your model. You get, so let's assume we have 100 features now, and you use feature selection techniques. You can use the feature selection technique to select, like, let's say, 30 features or 20 features. And those 20 features that we selected, they are the best features, that the features that have more impact or the most impact on on your model. So that is what it is. So it discards the remaining features, it just throws them away. But now this dimensionality reduction technique, it works in a different way. It doesn't actually select features. It just kind of perform it does something basically which reduces the feature to a certain number of features that you want it to be, while retaining or maintaining every feature in that data set. So you're not actually discarding any feature, but you're kind of it's just like compressing it to be smaller. So compressing all the information in all the feature information to be in a smaller dimension. You understand? Let's say you have 100 features and you use dimensionality reduction technique. What it will do is that it will reduce the dimension from 100 to like 30. But it is not discarding any feature. It is using the information in all those features to generate 30 new features, and you get to know what it is called. They are called principal components. So the new features that are created, they are different from the original feature. They are like a new feature, like that is a representation of your original features. So you have, like, let's say, 30 principal components that are like representing the 100 features that you had initially. So I'm actually already explaining PCA because PCA is a common one here. So PCA is we'll look at it, is one of the dimensionality reduction technique. T-snare is also another one, but is not used, is not commonly used for ML, it's used for visualization. When you want to visualize a high dimensional data set, and it's impossible to visualize above 3 dimensions. So TSNet can help you to bring down, let's say, your 10-dimensional data set into a proper a proper dimension that can be visualized. So we're not going to be looking at TSNet, but it's another technique that is used in reducing dimension as well. Now, PCA is what we're going to be focusing on here for dimensionality reduction. So it's reduced dimensions by finding new axes that capture the most variance. So now in PCA, there's a lot of mathematical concepts, linear algebra, and all those abstract things that goes into it. We're not going to look at them, right? But I'm just going to give you an idea, an intuition of how PCA works. So that is it for dimensionality reduction technique. Now, I hope everyone can still hear me. So yeah, now feature selection, as I explained, it's used to select a certain number of features and discard the remaining. So we have several types of feature selection techniques. We have the filter method, we have the wrapper methods, and we have the embedded method. So we're going to look at them one after the other and look at how we can use them. We can implement them in Sklearn. So the last one we have here, remember we're talking about strategies to what mitigates the cost of dimensionality. So the last one is regularization technique. So we are going to look at this as well. So yeah, let's move on. So I think we have a lot of ground to cover today. So in conclusion, the cost of dimensionality makes high dimensional data challenging to work with, but using techniques like dimensionality reduction, feature selection, and regularization can help. Understanding these strategies is key to building effective machine learning models. Now let's look at the first one we have. So the first one we have here is called principal component analysis. All right. So we have principal component analysis, also known as PCA. So PCA is an example or a technique that is used to reduce dimension, and a very popular one. So we'll quickly look at that and see how we can use it in Sklearn. So principal component analysis is a dimensionality reduction technique, as I have said. All right. That is used to reduce the number of variables in a data set while preserving the most information. So I explained this already. I said that in PCA, you don't actually discard any feature. You just try to reduce the number of features or the number of variables or the dimension, yet still preserving most of the information in that particular data set. Remember that features carries information. So each feature have a certain level of information that it carries, that it is used that impacts the model, right? So you want to make sure that you don't lose all those information, right? So PCA helps you do that. It reduces the number, it solves that problem of dimensionality while still retaining most important information, while still retaining most information in the original data set. Now, how does it work? I said that it achieves this by transforming original variables. So when you use PCA on a data set, the results that you get, the new data set you get, is not the same features that you have initially. They are actually new sets of values, and they are called principal components. So you see how this is used in Sklearn. So that's just what I want you to know, that they transform the original variables into a new set of variables called principal components. All right. So let's just move ahead. How does PCA work? As I said before, I won't want to go deep into all those nitty-gritty and all those things. if you want to learn them, you can just do your research. All right. So, but what happens in PCA is that PCA tries to maximize variance. Remember, I told us before that variance corresponds to what? Information, right? So now sometimes these terminologies can be used in different ways in different contexts. There's variance that is bad, which is the bias and variance that we talked about in the previous class. And there's also another variance that is good, which is the variance in terms of information in your data set, right? Or the information in your model. So variance maximization is one of the things that PCA tries to do. So PCA identifies directions or principal components that maximize the variance of the data. I know this doesn't sound so intuitive at this point, right? It's not making a lot of sense, right? Because this is purely a mathematical process, right? So a diagram actually explain better, and I would see if I can get a video that would explain it using visualizations, because explaining this in this form is going to not be easy to understand, right? It's a very abstract concept. So, but right, PCA just it gets the a particular, it transforms the data set or the pictures that you have and just convert them into what we call principal components. And those conversions, they are based on the variance that is there at that moment. So if it's looking at the variance at different points, it's going to select that particular one that actually has the highest variance because it corresponds to higher information. So when you transform your features, let's say 100 features to 30 features using PCA, yes, definitely you are going to lose some information because you don't have you've actually reduced the dimension, but the information that will be preserved will still be high. Let's say you'll be still be preserving like 90% of the variance or 90% of the information that was originally in the 100 features. All right. So although you've lost some information because of the compression, it's just the same thing as when you are trying to compress a video that is like 1 gig, a 1 gig video that is clear, and obviously a 1 gig video will be clear because to store all those pixels you need more storage. So compressing the 1 gig video to becoming 100 megabytes, obviously you still have the same what video. You can still watch the video and understand and get all the information and all of that, but then some quality has been lost in that process. So some things were sacrificed in order to get that level of compression. So that is the same thing that's happening in PCA. You are compressing a high dimensional data set into a lower dimension. So there's some information that will be lost. But so what PCA tries to do is try to maximize the information that will be retained at the end of the compression. Yeah, so that's basically the key idea in PCA. So these other things here, they are still talking about what I've just explained. So these are concepts in PCA: variance maximization, orthogonality. All right. So we have the dimensionality reduction. So you can just look up these things if you want to go into more details. All right. So, but just understand that PCA is used to handle that issue of dimensionality, and it does that by creating new principal components that maximize the variance of your data or your initial data set. Yeah, so we're going to see how we can implement PCA with Sklearn. So today we are going to take them one after the other. I won't do like I did last week where I went through everything and then went on to the implementation. So we'll see how we can quickly do that in Sklearn. So let's start. Hope everyone is still following. All right. So now it's very very straightforward. Like using PCA is straightforward. Sklearn makes a lot of things very easy. So importing PCA. So to import PCA in Sklearn, you just have to import it from the decomposition module, right? So decomposition import PCA. PCA, all right. So this is how you import PCA. If you check it, you would let's import it first, all right. So you can just go through the documentation here. You see that PCA, principal component analysis, is a linear dimensionality reduction using singular vector decomposition of the data to project it to a lower dimensional space. These are all the things that happens during they're just explaining what it does basically. These are the arguments and all of that, but we're going to be looking at using just few of them. So let's import it first. Let's import our data set as well. So we'll be looking at from sklearn dot data set import let's load responser. We're going to be using this data sets. So now let's just set up everything. Come here, so data equals to load responser. So there's a particular argument that I told us that would include here to make every of this thing a pandas data frame. So can someone remind us a particular argument you include in the data set function that converts it into a pandas data frame? Can someone just remind us of that? All right. Then so the answer is what? As frame equals what? True. So you just have to do this and then come and say data dot data y equals to what? No y basically because let's just top data dot target, right? I also remember there's something I've not taught us yet. That should be ROC curve. I remember now. I've actually not taken time to look at ROC curve, which is a way to compare performance of several models. I don't know if I'm remembering that correctly. Please, can someone confirm if it has been done or not? Have I showed us how we can use ROC curve to compare the performance of different models? Oh, okay. So yeah, it's very, 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 very important. Very important. And we're going to look at it in tomorrow's class. Like it has to be in your project. Like it has to be in your project. So the ROC curve is a particular visualization that you would use in comparing performance of your different models. So we are going to look at this in tomorrow's class. So please ensure that you are there. Ensure you are present in class tomorrow. So yeah, let's just move on. Now we'll do this, we'll do that, and then let's check out our data set. So you can see now that we have, let's look at the shape. So we have 569 observations here for this data set, and we have 30 features. All right, so this is the shape of our data set. Now let's assume that this 30 is too much features. I want to reduce it to just 15. We don't want to work with too much features. Let's say we train the model and the model is overfitting. I want to reduce it to maybe 15 or 20 features. So we can actually do that using PCA. How do you do it? So we've imported PCA already. So reducing the dimension of our data set. So that's why I love Sklearn. Almost everything follows the same pattern. The first thing is what? Instantiate an object. All right, let me just comment that. Initialize a PCA object. So I'll come here and say PCA, which is the object name, equals to PCA that we've imported. All right. So we're going to just put the brackets here, and there's a particular parameter it takes, which is what? Number of components. Number of components. So number of components basically mean how many number of principal components do you want to convert reduce your data set to. Remember I told you that PCA converts your variables to what? Principal components. So if I want to convert it to just 15 components, PCM, principal component, I will write 15 here. If I want to convert it to 20, I write 20. If I want to convert it to 10, I write 10. Do you understand? So let's start with 15. Let's reduce our data set to just 15. So I'll put it here. Once I've done this, then I'll come here and say PCA dot fit transform. And then I'm going to put my data, and in this case I'm putting just my X variable, because that is where it contains all my variables, right? So what I'm going to do now, I'm going to run this. Let me just X transformed. So first off, I'm going to print x.shape and come here and print x transformed dot shape. So you can see it now. You can see that this was the initial data set here, and now this is our new data set. So we have a new data set that we can now work with. So anything you want to do now, you can now use this S transform. I can now come here. If I want to split it is going to be this one I'm going to split. So that's basically how you use PCA to reduce dimension of your data. Very, very straightforward. Like in just few lines of code, just 2 lines of code, I've done that. See how easy it is. If I change it to 10, you can see that it's changed to 10 as well. So now we actually would like to also investigate some other things. So if I want to know how much information each of the variable is contributing, I can use a particular method called explain variance ratio. So this PCA object I have here, I'll just bring it down here and say that explained variance ratio, and then just press enter. So you can see now that each of the 15 variables, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So each of the 15 variables that I reduce it to, they have their contribution to the they have a particular level of information that they carry. So it is represented by these numbers we have here. So you can just look at it there. So if you look at that, you see that some are lesser, some are higher, right? So if you remove this exponential stuff, you have 0. What 0, 0.9, 0.001, 0.0000. So this is just going to show you exactly how each of the variable here carry the information level of each of the variance level of each of the information. So if you want to read more, you can just look at that. You see that an array will. So yeah, that's it for PCA. For all these other things are just maybe you want to just like drill down into the PCA. So each of these, they are new principal components. Let's even print out the X trans to see what it is like. So this is the X trans now. They all look like, converted to data frame first. Import pg dot import standard as pp. So come here and see. Goes to pd.data frame and say S trans. So come here and say X here. So you can see now these are the new principal components. So you can see that they are different from display dot head. Display X dot head. So you can see now that we have two different data sets. This is the initial data set, all right? The one that has 30 pictures that was now transformed. Let me put this one up and bring this one down. So this initial data set that was transformed into 15 variables. So you can see here that the principal component, they are new sets of variables. These are all these numbers, they were computed during the principal component analysis process. And then they were now assigned to the principal component, number of principal components that was created. So that were created. You see that the values are not the same thing. So he just tried to compress this initial data set, the number of features, he compressed it, and this is the compression results. So this is the data that you now use to train your model. So this data point, that will not make sense to you. They won't actually make sense. But they have information that they are carrying. All right, they have information that they are carrying, but they don't make sense. You can't say this one is the you can't say this one is like, let's say, mean compactness, or this one is the mean concavity, or this one is maybe the weight or the height or anything. Everything has been combined, and the information that were necessary were extracted to form this principal component. So that's what PCA does, all right? So if I change it here to any number of components, it's going to give me the same number of principal components corresponding to it. So that's just it. So you can try it out in your data set. Once you convert all your data set to numerical values, you can now just use PCA. If, let's say, your model is not giving you a good accuracy, you can use PCA to reduce the variables or the features and try different levels of PCA values or principal component, and see whether it's going to impact the accuracy or not. Understand? So machine learning building machine learning model is a very experimental process. So it's not something you just do once and you've gotten. So that's why I said, please take your time to do your projects. Someone submitted already, and it's as much as it's good to submit on time, I still need you to actually take your time because it's an experimental process. I want to learn. I want you to learn a lot. I want you to learn how to approach all these things and using different techniques and trying out different things like that. So it's easy to just write your code and your model and all of that, but explaining the idea behind it, how you arrived at it, why you use this thought, why you use this number of principal components, why you use this number, this value, this particular technique, and other one. Those things are what makes you. Those things are what make you a data scientist. You understand? So this is for PCA. Let's move on to the next one. So I hope this is clear. This is clear. This is clear. If you want to go deeper into what PCA does, I'll try to see if I'll find a video that will explain it visually so you understand better. All right, let's move on to the next thing. Yeah. So you can see the conclusion here. PCA is a powerful technique for dimensionality reduction that is widely used in various fields such as machine learning, image processing, and data visualization. It allows us to reduce the complexity of high-dimensional data sets while retaining most of the important information. All right. So by understanding and implementing PCA, data scientists can effectively preprocess the data and improve the performance of the machine learning model. So PCA is a data preprocessing technique, if in case you don't know. So let me check. There's a particular thing I want to see. Explain variance. Okay. So yeah, PCA is a data preprocessing technique. So it's also under it as well. So you do it before you start training your machine learning model. Now we looked at PCA as one of the technique that is used to handle the issue of what? It's one of the techniques that is used to handle the issue of dimensionality. Okay. So the second one we mentioned is what? Feature selection. So feature selection is another approach to reducing dimensionality. And as much as PCA is nice and all of that, feature selection is a very good one as well. It is more, should I say, specific, right? Because you have to choose features that are not contributing much to your model, or that will not contribute much to your model. So we're going to look at some of the techniques and some of the approaches is selecting certain features. All right. So now, what is feature selection? Feature selection is the process of selecting a subset of relevant features for use in model training. It helps model improve performance by reducing overfitting, enhancing generalization, and decreasing computational cost. So with the same example we gave the other time, you have 30 features. Now, if you use PCA will just compress it for you, not removing any feature, to give you a new set of features, quote unquote, called principal components. All right. But feature selection techniques, they are different. These ones, you know that these features, you are not selecting them. These features, you are selecting them. So when you perform the feature selection technique, the data you are getting right after feature selection is still the same data in your initial data set, but with some features dropped. Right, so we're going to look at how we can do that. There are different methods of approaching it. So let's get to it. But before we start, we need to know that feature selection requires you to have domain knowledge. You understand? Domain knowledge is important in feature selection. Just take for instance now, you want to perform you want to train a machine learning model in a medical sector for a particular medical task, and you have like let's say 50 features, all right, that is like going to be used in predicting a particular disease. Now, do you think someone from, let's say, that doesn't have knowledge of medicine or medical field generally can just come and start telling you that, oh, based on his experience, he doesn't think this feature will be able to predict this disease well enough. No, you have to already have experience in that particular field. You have to be, for instance, a medical doctor will be in a better position to tell you whether this feature is a good prediction for this disease. Do you understand? So it's going to require you to have domain knowledge in some certain when it comes to feature selection. So that is where maybe you want to just manually drop your some features from your data set. You will automatically that this feature is not important, it's not relevant. So that is actually the crude approach. But Sklearn gives us some automated way of doing that, which we can just easily select our features based on some metrics. All right, so each feature would be assigned scores. All right, so those scores is going to be used to determine which one is going to be kept. The ones with the lower score would be removed, and the one with the higher scores would be retained. So let's move on. So let's quickly go over it briefly and then dive deeper. So why feature selection? So I've explained already, improved model performance by what reducing overfitting, reduce complexity, and what speeds up training. So whenever you reduce the dimension of your data set, these are the things that you can get from that. So now, what are the types of feature selection method? I've been mentioning that over and over again. We have 3 categories, right? Under those categories, we have several subtypes. So we have the filter methods, all right? We have the wrapper methods, and we have the embedded methods. So the filter method, it uses statistical measures to score and select features, all right? Wrapper method uses a predictive model to evaluate combinations of features, while embedded method perform feature selection during model training process. So we're going to look at all this in detail. So let me start with filter method. So now you can see that's why I included this diagram here to just explain it better. So the filter method now, it uses statistical measures to score and select features. So what it does is that it selects features based on how much contribution it has or how correlated it is to your label. Right? So it compares a particular feature with what the target variable and see how close they are or related they are. It compares the second one and see. So each comparison will give you a particular score. And when you do that for all the features, you have set of scores. So you can now know that, okay, these ones with the higher score are the ones that will be better used in your model. So you can just retain those features and discard the features that have lower score. So that is the idea behind filter method. So what it does, these are the steps. It's first you have to get all your features right. Then it then selects the best subset. So the selection process is what I just explained now. And then that best subset will now be used in training your algorithm. Okay. And then you can now get your performance. So it's just straightforward, actually, very straightforward. So wrapper method. Let's even just look at them here. So this is filter because I don't want to repeat myself again. So filter method now, as I have explained what it does already, right? It compares each feature with the target variable and then get a score, right? So although there are 2 categories or 2 types approaches in filter method, we have select k best, which is actually the one I just explained now, and we have variance threshold. So the one I explained where I talked about comparing the feature with the target is for select k bests, right? So it selects the top k features based on scoring function. Why the second one, which is variance threshold. I've said it repeatedly that variance what refers to information. So the higher the variance, the higher information is contained within that particular variable. So for variance threshold method, the variance for each feature is computed, okay? And then depending on the variance value, the feature will be selected or not based on the threshold that we indicate here. So let's assume that we have 10 features and the variance was computed for 10 of those features. And let's say out of those 10 features, 3 of them had variances that were lower than 0.1. So if you use the variance threshold method filter to filter those features, the resulting features is going to is going to exclude those 3 features that have their variances lower than a particular threshold. That is the idea there. You are trying to filter your features based on the variance level. That is for variance threshold, and select k best is what I explained already. So these 2 methods are for filter methods. Okay. So we have the wrapper method now. Wrapper method is as I'm explaining here, it's set of features, right? You have to get your features first in your data set. And now what it does is that it considers a subset of all features. So the process of selecting the features is not your headache, right? It uses different techniques in selecting the features, but you can indicate the number of features it should select. All right, so it does that for several subsets. So let me go back. It considers several subset of features, and then it trains an algorithm. It trains a model. It trains a model, and then out of the different subsets of features that it has selected, the subset of feature with the best performance, model performance, is what will be selected, right? So now it is embedding, or it is wrapping model training with feature selection. So that's what wrapper method is. So it is wrapping feature selection in training of your model. Okay. So that is for wrapper method. And then we have the last one, which is embedded method. So the embedded method is just like is an algorithm itself, right? It's like, let's say, as we have linear regression, we have logistic regression, we also have another algorithm that has this feature selection technique built into it. So we have something like lasso regression, we have ridge regression. So all these are kind of modification linear regression that has this feature selection technique embedded into it. All right. So once you train that model, it's going to just automatically perform all these things here and then give you a performance. So we're going to look at how we can implement all of these things one after the other in the skill. And I think by then you will even have a better understanding. So let's start with the filter method. Okay. So today's class is not supposed to be lengthy. So let's proceed. All right. Feature selection. All right. In Sklearn. Okay. So first of all, you have to import them. All right. You have to actually import them. So hope everyone is still following. Please, I need feedback. I think today is quite dull in terms of feedback. So please let me know. All right. All right. Okay. So that was okay. That was okay. Okay. So as I said, the first thing you always do whenever you want to perform anything in SQLN, whenever you want to perform anything in SQLN is to import the things that you want to use. So for this feature selection process, everything they are under so from SK, everything is under feature selection model, feature selection, import. So I think you just come here. You import variance threshold. Import select key best. Think yeah. So let's look at these two first. Let's look at them first. So now we reported them, although you come here, you already have your data set, right? We have our data set we loaded already, so we're going to be using the same data set. So now to using filter method to select features. So now we'll start with variance threshold, all right? So the process to applies to variance threshold, like almost everything in Sklearn follows the same process. You import it and then you initialize what's an object, right? And then you fit and transform that on your data set to get an output. So that is what we're going to do here. So what you do is just initialize, let's say var thresh. So you come and say variance threshold is a class. Now there's a parameter that you need to specify there. It's called the threshold. Now, if you go to the documentation, you'll see it that feature selector, variance threshold is a feature selector that removes all low variance features. So this feature selection algorithm only looks at the feature and not the desired output. So unlike the select key, which looks at both the feature and the output, this one doesn't, all right? So it takes the threshold. So what the threshold is features with a training set variance lower than this will be removed. So let's say if I come here and I say 0.3, all right? And I run that, come here and say var fresh dot fit transform. So what am I going to put in this bracket here? Can someone tell me? What am I going to put in this bracket? Can someone tell us what we are going to put in that bracket? Just two persons. All right, so let's just proceed. So yeah, of course, we're going to put our x variable there, and then we'll say x3. So let's just say s3. This one here would be x2. Or let's just say s2. So if I come here and say s2 dot shape, so you can now see that this variance threshold has removed how many let me print out the all right, so you can see now that the initial shape of our data set was 30 and 596 with what 30 features. So after the feature selection process with a variance threshold of 0.3, we can see that it has reduced to just 11 features. So for this variance threshold, you can see that we don't specify the number of features. It depends on the threshold of the features that is in our data set that will determine it. That will determine the number of features we will get. If I change this to 2, let's see that we still have 11. Let's see if we change it to 1, still 11, right? Let's change it to 5. So you can see now it has changed to 10. Let's change it to 9. So the same thing. So let's see. Okay, feature with the training for this to keep all features within non-zero variance. Okay. So yeah, so that is basically it. Depending on the threshold value that you indicate here, the default is usually 0. So if you put 0 there, you'll see that it still retained all all the features that we had initially in our data sets. Okay. So please give me a sec. My screen is not clear. So all right, so All right, so sorry for that. So yeah, let's just continue. So yeah, this is just what you do you using variance threshold. Now, depending on what threshold you want to use, you can just indicate it here. And also, there is a method or function that you can use to see the variances of all the features in your data set. Let's see, it should be dot variance, right? So you can see that everything here, these are all the variances of the 30 features that you have. So it will look at all these variants and then look at the ones that are lower than the particular threshold you have here and then select them. Do you understand? So that's just it. So if I say this one is going to be 0.001, you can see that you selected 19 features. If I say it's going to be 0.0114, if I say 0.00125. So it just depends, right, on how much variance you want to allow, right? How much variance you want to allow. So 0 means what? No variance. 0 means no variance. That means if your data set has a particular variable that has 0 variance, no variance, it's the only one that is going to be what removed. So but if you start to adjust this value like that, you're going to be getting some features that are to be removed. So according to the value put here, you're going to have different number of features, so 24 here and all of that. So this is just one method for getting or selecting features. So the other one is k-best, using select k-best. K-best. So the same thing happens using this method. You just say k-best, also select k-best. So now k-best take a parameter, which is called score func. All right, it takes this parameter called score. Let me see. Yeah, so score func. So the score func takes various values, right, and it depends on the task that you're performing. So this is a very important aspect of this. You need to pay attention here. Now, you can't just use this k-best like that. You have to indicate the parameter, which is called score func. So now, in this case, we are working on, I think this load breast data set is a classification data set, all right? So now we have how many of them here? We have the F-classic, we have the chi-square, we have F regression, and we have mutual info regression. So if your label or your task is what classification task, you can use F-classic, all right? If it is a regression task, you use F regression, all right? If your target is a continuous target, you use mutual info regression. If we have other ones here actually, so these are the ones that are common: this F classic, mutual info classic, chi-square, F regression, mutual info regression. So chi-square is actually the most commonly used, I guess. So it is used for non-negative features for classification tags. So when your feature is non-negative values, you know what non-negative values are? That is positive features. Values, that is continuous, non-negative values, positive numerical values. Then you can use chi-square, right? So this is the rule that you'd have to follow when selecting the particular scoring function, because this is the scoring function that will compute the score for each of your feature in relation to your target variable. So in this case, we're going to use chi-square. Come here and say chi-square 2. All right. So that is So yeah, we're going to use chi-square there. And then there's another parameter that is called k that we also have to indicate. So k is basically like how many number of features do you want to select. Remember, it's select k best. So you just say I want to select 15 of them. So it will use this particular chi-square to compute that score, and then out of the scores of 30 features, you select the 15 that has the highest scores. So come and say k best dot fit transform. All right. So for this particular one now, what are we going to use inside this bracket? Quickly. I just want to be sure that we are following here. What are we going to use inside the bracket? What are we going to put inside the bracket? Any other person? Okay. So none of us actually got this because it's different from what we did the other time. If you listen to what I said, that this select key best compares what the each feature with what our target. So for it to make that comparison, we have to put both of them here as arguments. You can't just put x. If you put just x, what is it going to compare against? Understand? So that is how it gets the score. It is for variance threshold that it uses just x because it's not making any comparison. It is just computing the variance for each feature, right? So that is basically how you determine what to put here. So if let me just follow you and put the x here, you can see that we are getting an error. All right. So you can see, let's scroll down to see. Let's check first. And just check to be sure. Okay, this chi-square should not even be here first of all. This quote should not be in chi-square. Okay, we have to import this. Yeah. So those scoring functions have to be imported as well. Where did I import all those things? What did I import them? Okay. Yeah. I have to import the scoring functions as well. So I'll just come here and say chi-square. I'll say f plus if. Just import these two. So I have to actually import them and then use them here. So you see that now we are getting the real error, which is what expected array, like blah blah blah, all of that. So now if you put the y, you see that we are having what an output, because that is how it gets this scoring function and compute that. So I'm going to just come here and say x3 and just so if I print the shape of this as I did initially, so come put this x shape x3, say print features using select key best. What was happening to do? So, all right. So you can see now that we are using select k best now. So we have our feature 30 initially, right? So we use select k best to select 15 of them, and then the resulting shape is what 15. So these are just different ways of selecting our features. We've looked at the filter method now, which comprise the variance threshold and the select k best. Very straightforward to implement in Sklearn. So this one is using what variance threshold. So you can see. So yeah, that is it for filter method. Now let's go to the next one, which is the wrapper method. Going to look at the wrapper method. So the one that we have is RFE, using RFE, recursive feature elimination. Okay, so to use, let's go straight to our notebook. Check that the variance threshold already and the select k best. So the next is recursive function elimination is under that method. So what it does is that it recursively removes features and build models to identify the best subsets. Now, remember I told you that in this place when I was explaining it, that it takes a subset of feature, train a model, take another subset, train a model. What actually happens is that it starts with the full feature, train it, and then go the next iteration, it will remove one feature and then train it. Next iteration will remove another feature, train it. So it does that until I think it's remaining one feature or so. That is what happens when you use recursive function elimination. So I'm going to show you how we can implement that quickly. So you have to import that the same way you imported all these other ones here. So from featuring, you have to import RFE. So how exactly does this RFE work? So RFE works together with a model. Remember I said you train a model with it. So you have to also use a particular model. Let's say in this case, we want to use logistic regression, all right? So we're going to basically just import logistic regression as well. So I'll come here and say import. How am I always going? See why it's good to always put everything together. So let me just put everything here. All right. Importing object selection. So I'll come here and import, let's say, logistic. Oh, why am I doing this? From Sklearn dot linear model, import logistic regression. So yeah, to use RFE, you have to first initialize the logistic regression. So you come and say log reg dot logistic regression, right? Then RFE. So RFE takes two parameter. The first parameter is the model, in this case log reg. The second parameter is number of features. Let me check this to be sure. All right, estimator and end features to select. So Let's quickly go through it. So the estimator is a supervised learning estimator that will be used. So n feature is the number of features you select. Okay, if none, half of the features are selected. If integer, the parameter is absolute number of features. So this is just telling you that if you don't indicate this particular parameter here, half of the features will be selected. So, but if you do, the number that you specify will be selected as well. Be selected instead. So I'm going to just come here and say just choose same 15. Let's say 13 because 15 is half of it. So to come and say x4 equal to rf.fit transform. Now in this case, what am I going to put here? What am I going to put here? What am I going to put here? Based on, well, just look at the context and just let me know, am I going to put just the X, the features, or am I going to put X and Y? Nobody's saying anything. Is it like, can you hear me again or what? Let me check. Yeah, because of time, yeah, we are going to put X and what Y. Because we are training a model, so we need the two data sets. We need the X and Y variables, all right? So all this is just one in. Just change this and ether. So max ether is 2000. Oh, still okay. Let me just ignore the one in itself altogether. Import earnings. Just earnings. Dot filter earnings. No. So I don't have to put anything here. Let me take my time. All right, so now this is what has happened. Let me print it out the same way I did this. So if I come there, and I say using RFE, so you can see the same thing. No, I'll X4 shape. So you see the same thing. So we are literally achieving the same feature selection using different methods. So you have a lot of options to pick from here. All right. So when you are doing your project, you can now know which one you might want to use for your feature selection. You can use variance threshold, or you can use select k best, or you can use a wrapper method instead. All right, which is RFE. And just know that all this feature selection, the output that you get is usually the features that's selected, right? So you can now convert that feature to a pandas data frame if you want to, but it is absolutely not necessary, all right? and you can just go straight to building your model after you've selected your feature. So that's it for that. The last one here is embedded methods. So these embedded methods, they are just like a model, like a separate model that performs this feature selection internally. Okay, so we have an example here, which is lasso regularization. So it's a built-in method in SQL, a built-in model rather in Sklearn that adds a penalty for high coefficient value. So what this means is that it looks for those features, some features that are not like that are causing overfitting, basically, right? Then let me just put it that way, and penalize them. So in that process of penalizing it, it kind of eliminates that feature from the data set and use other features to build the model. So the process of doing this has made it to be included as part of the feature selection technique. So lasso regularization is a type of a model, or is a type of algorithm in Sklearn. Is an adaptation of linear regression actually, but in this case, it is actually they have a regularization implemented to prevent overfitting. So when you use linear regression and then you are having overfitting like in your model and you are seeing that your model is overfitting, you can just actually use this lasso regularization. Lasso regression, it's called lasso regression here. So you use it and it performs all these things and tries to prevent overfitting. And in the process of preventing overfitting, it can eliminate some feature inside the data sets used. So that is basically what this embedded method is. So we're not necessarily going to look at it because there's really nothing to look at there. You import lasso from linear model. You can see lasso. Let me import it so we can read the documentation together. So I'll come here and say lasso, right? So if I just press my cursor, you see that this is what a linear model trained with L1 prior as a regularizer. So this is it, just see it as a linear model. So when you see linear model, linear regression, it's the same thing as lasso regression. It's just that lasso regression is an adaptation of linear regression that has a regularizer. Regularizer is something that tries to prevent overfitting. So in the process of preventing the overfitting, it can actually eliminate some features, those features that are actually causing the overfitting to happen. So that's basically what happens. The other model we have that prevents overfitting is ridge regression. So ridge is another adaptation of linear regression. So it's a linear least square with L2 regularization. So all these things, we are going to look at it in tomorrow's class, regularization. But for today, we are looking at feature selection. So these are the three methods. So the ones you'll be using most of the times are these ones, so filter methods or wrapper methods. So you can just select the one that you feel more comfortable with. All right, so that is it for feature selection. So we've actually looked at PCA and we've also looked at what feature selection. Now we have one more thing to look at today. It's called pipeline. So let's just quickly conclude. Feature selection is crucial to building efficient and effective machine learning models. SQL has various tools to perform them as we've done already. So by selecting most relevant feature, you can improve model performance and reduce computational cost. So all these things are just part of pre-processing technique, the pre-processing step in ML. I consider there are a lot of things that we can still do. Even at that, we still have more things that we never looked at that you can do in pre-processing. So you see that machine learning model is not about saying model.fit. There are a lot of things that will follow or that will precede it so that you have a very good and high performing model. So the next thing or the third thing on today's outline is pipelines. Now, pipeline is not necessary, right? But it can help you to streamline your pre-processing steps. It just simplifies the workflow for you. And when we look at it, you'll be like, wow, that this actually makes the code looks even more organized and neat, right? So it's not like is a technique to do preprocessing or anything. It's not a preprocessing technique. It's just a method or a way of streamlining and just arranging our code in various steps. All right, so I'm going to just go through it now. So in machine learning, a pipeline is a sequence of data preprocessing steps applied to data. So Sklearn's pipeline class helps streamline the process, ensuring that all steps are executed in the correct order and simplifies the workflow for model training and evaluation. Why use pipeline? It streamlines workflow, it ensures consistency, it enhances reproducibility, it also simplifies your code. It simplifies your code. When you see a code that used pipeline and a code that didn't use pipeline, you will know that there's a difference in how simple, the simplicity of the code. All right. So let's look at it. Now there are two components in pipeline. We have the transformer and we have the estimator. So we'll look at all this and it will make a lot more sense to you. So now let's quickly go to how we can implement it. So first off, we're going to come here and so if you use pipeline in your project, just know that you're already getting extra additional mark because your code will definitely be more organized. So this is just a tip I'm giving you. All right, using pipeline in Sklearn. All right, so now pipeline is used for preprocessing, as I said. And when you actually want to preprocess your data, you preprocess or you perform some transformation techniques. And now I'm going to use Sklearn data because Sklearn data is kind of preprocessed already. I'm going to import a data set and then we're going to use it and you're going to see how we can use it practically. So I'm going to import df, say pd.read csv. And I think we have retail transaction CSV. Okay, so now you already know this retail transaction. It has both categorical and numerical variables. So I'm going to be dropping these dates. So I will just come here and say df equals to df.drop. I will say what is wrong with me this afternoon? Why am I just typing transaction date and axis equals to 1. All right, so I want to drop this and the customer ID as well. Customer ID, right? So I'll put this in a list. Okay, so we have this, and let's try to use pipeline to preprocess it, but let me reduce the columns first of all. So small letter columns equals to df dot columns dot string dot lower. Alright. So. Okay, now using pipeline to preprocess our data. Okay. So now, in this case, all right, let's just continue. So first of all, before you use pipeline, you have to separate the data into categorical and numerical because you cannot apply the same preprocessing technique on the numerical data and categorical data. You have to preprocess them differently. So you have to separate them. You can come and say categorical cat vars, all right, and you come and say pd select select the types, right? Select the types, and you say exclude equals to np.word numbers. Are you kidding me? When was I mute a big? Because I've been speaking for a while now. Was it just now? Okay. Come on. I was thinking it's been a while. I think it was network. So let's just continue. I will stop. So please, where did I stop? Where did I stop? Okay, when separating variables. Okay, thank you. So yeah, I was just trying to say I think we've done this before, so it shouldn't be a new thing. Exclude. So okay, so now we've separated this, right? So now the reason why we did that is because we want to apply different processing techniques to the different data types. We can, as I said before, we can actually do the same thing on both of them. So let's just proceed with that. Now we'll come here and say pipeline or cat pipe, categorical pipe, because we want to perform the transformation on the different ones. You come and say pipeline. But before then, you have to import pipeline. So come here and say import from Sklearn pipeline import pipeline, right? So we'll just come straight here and say pipeline. So pipeline takes some arguments. If you open the documentation, you see that it takes an argument called steps. Very, very important. So the steps are the steps or the preprocessor steps you want it to perform. So steps here is going to be in form of a dictionary. I think a list, actually, not a dictionary. Should be a list. Should be a list. A list of tuples. Right. So the first tuple is going to be the first thing you want to happen. So let's say for your categorical variable, you want to do simple imputer. You want to impute or replace the missing value. So using simple imputer. So in your tuple, you have two values. You have the name of that processing technique, and then you now have the preprocessing technique itself. So it should be simple imputer, and then you have your strategy. We've not imported this yet, so most frequent. Right. So that's for imputer. Then after you view the missing value, you now want to encode it. Okay. So the next step will be encoder. So it will be using one hot encoder. So you can just say sparse output equals the word true. So these are the two things you want to perform on your categorical variable. So you do the same thing for your numerical variables. Come here and say numerical pipe actually, the pipeline for numerical. You do the same thing, pipeline. You come here and you say steps. You say equal to, it should be a list of tuples. So the first thing you want to perform on your numerical variable is also you want to do the simple imputer as well. So you come here and say imputer. So this imputer, this first part, you can name it anything actually. Come and say simple imputer and say strategy equals to what? Mean. And then after that, you now do your scaling. And come and say, let's say you want to use standard scalar. All right, so you can see that we've just defined the processing technique for each of the variable type here for both categorical and numerical variable. Now we want to combine them. After we've processed them differently, we want to now combine them into one data set. So there's what we call column transformer in Sklearn. Using column transformer to combine the two steps or the two types, all right? So please, I think my network is misbehaving. Let me switch network. Just give me a sec. What's really happening? If this persists, then we'll just stop here for today and continue tomorrow. So let me see if we can just round off with this. We're actually almost done, so just some few more steps. So all right, so now for column transformer, we'll just come and create column transformer and say column transformer. So column transformer it combines the numerical pipeline and the categorical pipeline, right? So, and it's usually in a list of tuples. So the first tuple is going to be let's say categorical pipe. All right, you can now come and say the categorical pipe, and then it will take the last thing in the tuple, which is going to be the categorical features of vars, sorry, categorical vars. So the same thing will apply to the numerical one. So you can just say, remove this, just say cat, and then num. So anything that is on string in strings, you can name it anything. So the other one, numerical num pipe, and what's num vars. So these are the steps. Now, you might be confused and like all this might be looking new to you, but trust me, once you do this, you are going to see how it helps streamline and just arrange everything. So you can see how we are putting everything in different pipelines, right? So if you have more processing technique, you can actually put it here. Let's say we have PCA. You can come here and say PCA, PCA, and just like that. You understand? So please, Chukwuka, is it just your is it a general thing again? I honestly I don't know again. I've switched network. Is it just one person or is it general? Okay. All right. So once you've combined the two pipelines, then you can now create the final pipeline. So before you create the final pipeline, you would have to include or create your model, right? Initialize your model. So in this case, we're going to be using our logistic regression model. So I'll just come here and say log reg. Okay, we've already initialized logistic regression model before, so I'll come and say final pipeline, or final pipe is equal to pipeline, and then we'll come here, and it takes a step stuff here. All right, and then we'll have the first tuple, which is going to be, we're going to call it preprocessing, and then we're going to pass in this combined pipeline here, right? And then after this, we are going to pass it into this. We're going to, let's say, want to reduce the features using PCA. So we can say PCA equals to PCA and components equals to, let's say, 21. After that, then we'll now train our model, right? We'll now pass into the model. So model equals to log reg. So this is it. Like this is the pipeline for everything. So I'll just come here and carry this final pipe. Instead of train the log reg, I would just say final pipe dot fit, and I will say x and y. So remember in this case, in this case we are using this particular distance, so we're just going to use this discount applied as our y variable, although it won't really make sense. So let's come here and say y variable x is equals to df dot drop discount applied axis equals to 1, and then we have y equals to df dot discount applied. So this is going to be our x and y, so we're just going to come here and see where it goes. Cut volume, be sure that everything is okay. This should be a list column to list that column to list. All right, so line 8. I'm trying to find out where the error is. Okay, I think it's here. Again. Okay, I think it's here. That's 1. I think should be here. Columns. All right, so we've already, all these things you're seeing here, that the pipelines. So you selected your categorical variables and your numerical variables into a list, and then you build a pipeline for categorical variable. What you did here is just specify the processes that it will go through in the pipeline. So the first thing is just the imputer. After it has gotten the imputer, it will now encode it. So here you're not putting any data here. You're just defining the pipeline, the process. You define it for the categorical, you define it for the numerical. Then you now combine the two pipelines together. After it has transformed the data, it will now combine it into this combined here. So it will not be a single column, right? After that, you can now create a final pipeline that will use this single column and then reduce the PCA and then train a model on these features that have been reduced here. Oh, principal component 21 won't make sense because our data set has just 1, 2, 3, 4, 5, 5. So I'm just going to put 3 here. So I'll run that, and then so it is in this point, at this point now, that all the thing that you have defined here would now be executed. So if I say fit xy, is hopefully not going to give us this. Okay, what's the problem now? A given column is not the column, okay, of the data frame. Are you sure? A given column is not the column of the data frame. What is the x? X, what is x? X and y. this is y, right? And then, okay, so I think we're going to just put x here and x here. All right. So come here and do this. Y contain NaN. Okay, so let's just drop NaN for y. Y dot drop Na. In place equals to true. Fill NA fill NA comment to measures dot fill NA equals to y dot min. So in place equals to true. All right, so hope you are following. Just trying to set up some things. What is the problem? What's the problem? Okay, nobody even pointed it out for me that I'm using logistic regression on a continuous variable here. I don't know if we are still following at this point. Let's come and say linear regression. Linear regression. All right. Come and define my linear regression. Linear reg is equals to linear regression. All right. So come and just say lin reg. So let's see. So you can see that our pipeline has been created. So this is basically the pipeline. So it shows you the steps from beginning to end. So preprocessing, column transformer, the norm, you can see the categorical variables here, the simple imputer for the categorical variable, simple imputer for numerical variable, one hot encoder for the categorical, standard scalar for the distinct. Then you now combine both of them using column transformer. So this whole entire thing here is column transformer. So, and then after that, we now pass it into PCA. Right, you can see the PCA is 3. After PCA, we now pass the data to our linear regression model. And then we have our model. So this is the entire process of creating a pipeline. So it actually shows you a very good summary of the pipeline that you've created here. So yeah, that is it for pipelines. You might not understand it now, but when you go over the video again, I think you would be able to grasp it better. So if you have a data set that has just one variable type, there will be no need to separate it because you can just perform the same processing on all of them, and there will be no need to use column transformer because you're not combining anything. You just do your pipe for the entire thing and then just pass it straight, pass the straight to your model here and just say plain reg. All right, so this is what you do when you don't have multiple data types in your data set, which is rare. That's why I wanted to take you through this process where you have multiple data types. So if you now multiple data type, if you have just numerical variables all through, you use just one pipeline and you pass every step straight up. You understand? when you pass every step, you just bring the pipe. Pipe will just come here and say pipe dot fit, and you say X and Y. You understand? So that's basically, it's actually straightforward. The reason why it is this long is because we have our data set has multiple data types. That's categorical and numerical. That's why we have to specially do the pipeline for each of the different categorical variables and combine it, and then just create the final pipeline from there. So that is it. That is it for today's class. I really hope you're able to get something, honestly, because these are very, very useful features in Sklearn, useful techniques, useful methods, and all of that. If you implement them in your project, it will be really, really nice. Right, you also enjoy it as well because you see that you are not just doing the basic, you're actually trying something new and something more advanced in a way. So we are going to be calling it a day at this point. We've actually talked a lot and looked at a lot as well. So please, as usual, if you have any question, just indicate. I would be picking you. I'm unmuting you so you can go ahead, and then we'll just wrap up and close the curtain. So any question, please? Any question? I've been having any question? All right, Patience, please go ahead and ask your question.
Good evening, sir.
Yeah, good evening.
Thank you for the class this evening. Please, I want to ask about this pipeline in particular. If you've done your pre-processing partially and you want to do this pipeline, are you going to start from the beginning, or you just after you finish that one, then now use this pipeline to represent it again?
As I said, yeah, there's different options, right? This pipeline is just another method of doing pre-processing, right? You can see that it's made very compact and just make it your code simpler. The other method is the normal method where you do the processing separately for each of them. So I would actually prefer you to go through the steps that we've done or that we've looked at. But then you can as well, you can use the pipeline, just let's say, just do that one like separately, kind of. But there's some things that you'd have to do, including the pipeline, because you also be doing hyperparameter tuning as well. And all of those things would require you to adjust a lot of things in the pipeline. Wow, what? Okay, this is general now. Please, this is a general statement. Use the normal method for preprocessing. Okay, the normal step for preprocessing. You will still get your full mark. Okay, you would, whether you use pipeline or not, it will not affect how much mark you get. Right? But you can, after you've used the normal process, you can just, let's say, indicate that you can also use pipeline, and then you can actually write some code on how you can actually use the pipeline for the same thing and all that. But if you can't, it's actually fine. Like, you don't stress yourself so much. If you want to use just the pipeline, use it. If you want to use the normal method, use it. It will not affect your mark in any way for this particular part, right? So this is, I think, a general statement to everyone here now. So yeah, because I'm very certain that it might introduce, it might give you a headache trying to just switch to using this pipeline that you just learned. You might need some time to kind of understand it better so as you'll be able to implement it very well and all of that. So that's just what I have to say regarding that.
Okay, thank you, sir.
So please just stick with what you've done before. All right. Okay, Adiremi, please ask your question.
Good evening, sir.
Yeah, good
Thank
evening.
you for the lecture this evening. In fact, uh, you are a good teacher, because in the first place I lose interest, but the way you teach and the way you explain makes me to say no. I won't quit for this class. Please, this project you gave us, sir. The
Yeah.
project is not in Jupyter Lab. And
What do you mean?
although I've been very busy, so the day I want to try it, I find it difficult to import it to Jupyter Lab. Then two, the data that is there, is it the one we are going to use?
Okay, I don't know if I got the first question, but the data that I sent alongside the project document is the data you use. And I think, okay, the Jupyter Lab you're talking about is a different thing entirely. But assuming I understand what you asked, I didn't give you a Jupyter notebook, right? Like I do before. So you have to
Yes,
start
sir.
from you have to start you have to create a Jupyter notebook yourself and start from scratch to do the project. That is just basically what I expect. So there's
Okay.
no preliminary notebook that has the questions like the assignments. You just have to start everything from scratch, create a new notebook and start the project and follow all of the things that I asked you to do.
Okay, sir. Okay, sir.
All
Thank
right.
you, sir. I'm very grateful. All right,
Yeah,
sir.
thank you very much, sir. All right, Ginika, please ask your question. Ginika, your hands were raised up, so please ask your question.
Okay, all right. Good evening, sir. And
Good
thank
evening.
you for the lecture. It has always been awesome. So my question is, this pipeline, is this similar to function? I know I can build function, like I can use function to streamline my code. So is it similar? Is it something one can adopt? I don't know if you understand what I'm trying to
I
ask.
understand. I perfectly understand what you're saying. So yeah, functions is another way to streamline your code actually. Like you can write functions that will do a particular thing, and you can just use them repeatedly in your code. Pipeline is just very specific to Sklearn, right? And it's for like preprocessing. So it's not something you can use anywhere else. So Sklearn just has this particular um, functionality that can just help you to just put everything together, right? So from start to finish, especially during preprocessing, right? So yeah, um, it's kind of similar in that sense that you package things in an organized way, because functions you can also just define the steps that you want and then just call it later on. So the same idea is reflected here, where you define the steps in the pipeline, and then when you call pipeline.fit, it's just like calling the steps to be executed. So that's actually just it's I understand you. If you use functions too, it's part of the creativity I told you about. Like I have not used functions for us in class to kind of streamline our codes in machine learning, but if you use it, it's a plus as well. All right, so these are the kind of things that would actually help you stand out. So pipeline is not this pipeline I just taught us now is not compulsory. Like, let me sound it again. It is not compulsory that you use it. So if you go and use it and you don't use it well, then that is where there'll be problem, right? If the one you know how to use it very well. If it's the normal one, use it. If it's function, use it. If it's pipeline, use it. It will not affect your market anyway. My own is just that you should just make sure that you just follow the steps and you get what you want to do, and your code should be neat and organized. All right. So if you want to use pipeline and you want to use the other method and in the same notebook, feel free. All right. It's okay. So That's it. It's at the end of the whole thing, you are the one that is benefiting from it. I am not benefiting from it. I am not getting anything. You are getting your grade and you're also learning as well. So the project is not just for you to get grades and get certificate. It's also for you to challenge yourself and also apply things that you've learned as well. So that's basically it about that. So thank you very much, Ginika. Any other question?
Thank you, sir.
Any other question? All right, so I think we're going to have to call it a day here. I'll stop the recording. So please try to finish your project on time before weekend, or before 22nd. 22nd is Sunday. And as I said before, a certain number of persons will be selected based on your performance in your project to give your to defend your project, right? So all these things, they play a role in the bigger picture. So put your best. That's just what I'll tell you. Put your best, trust me. And this project is something that you can actually showcase. You can actually tell people that this is what I did in career, and they'll be impressed. You can put it on LinkedIn. You can even package it and refine it and put it as part of your CV project, as part of the project you've done in your CV, right? So from there, you can start and even add more projects to it. If this is your first project, it's going to help you to kickstart other projects that you might possibly do. So do your best, right? We're not going to be having any class again, no assignment. So this week literally will just be for you doing your project and focusing on all other things. All right. So thank you very much for your time. Tomorrow we'll wrap up with the entire thing, with the program. If there's any other special class, I'll let you know. Because think we might have next week free. So there'll be no class next week. So you just be able to focus on your project. So yeah, thank you very much for your time. Please do well to write out to let us know what you've learned today. I know there's a lot of things that we learned today. Just the specific things you learned in class today. Let us know in the live chat. Thank you very much and enjoy the rest of your day.